Alright, hi guys, and thank you for watching this video. Here we'll be going through 1.7 to 1.11 review, and we'll be going through all the questions from question 1 to question 9 of the review packet, which is also linked in the description below. Alright, so first of all, let's start with a few simpler questions. So use your formulas to answer each question below, leaving your answers in exact terms of pi. The first question. A semicircle has area 50 pi. Find the circumference of the whole circle. Okay, so we know that this part has area 50 pi, and then we want to find the circumference of the whole circle. So what is the formula for the area of a semicircle? Well, that's the area of the whole circle, which is pi squared, times 1/2. And this is equal to 50 pi. Therefore, we know that r squared is 100 and r is 10. Now, what would the circumference be? The circumference would just be 2 pi r, which is 2 pi times 10, or 20 pi. So we get 20 pi as our final answer. All right. Problem 2. A cylinder has base radius 2.5 and height 4. We want to find the volume of this cylinder. So for any cylinder, the volume is always equal to the base area multiplied by the height. And the base area is equal to, because it is a circle, it is equal to pi r squared multiplied by the height. Now we can just plug in our numbers. Yeah, and instead of calculating, and this becomes a lot simpler because we can write 2.5 as 5/2, right? And then we'll get a final volume of 25 pi from our calculations. Okay. Next question. A circle has circumference 10 pi. We want to find the diameter of the circle. Now you could go on and find the radius and then multiply that by 2. However, we have an even simpler way to just find the diameter, right? We know that the circumference of a circle, c, is equal to pi d. So if c is equal to 10 pi, then d is just equal to 10. Okay. A cone has a slant height of 13/2 and a radius of 6. We want to find the volume of this cone. You can assume the Pythagorean theorem. Yeah. So for this problem, how do we solve it? The slant height, which is this length, right, is 13/2. While the radius of the cone, which is this length, is 6. Now, we can solve for the height using the Pythagorean theorem. The height would simply be 13/2 squared minus 6 squared, or if you're familiar with triples, this is just the scaled down version of 13, 5, 12, because we are just dividing each side by 2. So we get that the height is equal to 5/2, and then to solve for the volume of the cone, we have that V is equal to 1/3 times the base area times the height. And we know the base area is pi r squared, so we can just plug that in. And then after all computations, we will get that this is equal to 36/3 pi times h, which is 30 pi. Right. Okay. Now we want to find the surface area of a cone if the slant height is 10 and the base radius is 5. So how do we find the surface area of a cone? The surface area of a cone is equal to the base area plus the lateral area. The base area is simple. The base area is just pi r squared, which is 25 pi. How do we calculate the lateral area? Well, we would have to think about the lateral area as a sector, right? Because when we kind of open the cone becomes a sector. But we need to know two things. The first thing is the radius of the sector. And here, the radius of the sector is simple. It is already given. It is 10. The second thing we need to know is like the angle of the sector. What is this theta value? And we can also find that. How would we find that? Well, you would have to look at the circumference or not the circumference, the length of the arc, which is this part. And this arc length, right, would be equal to the whole circumference of the base. So let me repeat that one more time. The arc length you get from when you expand the lateral area out into a cone is the same length as the whole circumference of the base. So this length, this arc length, will be equal to 10 pi. So now we can find this angle because we know the radius and we also know the arc length. So it turns out that this would be 180 degrees because the only way for a circle with radius 10 and an arc length of 10 pi is if we have 180 degrees, as this makes it 2 pi r times 1 over half. And yeah, which works really well. So now that we know that this is 180 degrees, we want to find this area. How would we find this area? Well, again, we would take 1/2 times the area of the whole circle. So we would get 100 pi times 1 over 2, which is 50 pi. Which means that the total is 75 pi. Okay, 5b. Find the surface area of a cone in terms of x if the slant height is 2x and the base radius is x. So this is basically the exact same question as the last problem, but we're just trying to generalize into x and 2x. So again, base radius is x, lateral area is 2x. So again, surface area equals lateral area plus base area, or base area plus lateral area. And the base area is just pi x squared. Well, the lateral area is what? The lateral area can be found by expanding the cone out to form a sector. And then we want to find, we know that it has a radius of 2x. We just want to find this length. And we can do that by taking the whole circumference of the base. So the base has circumference 2 pi x. And because this sector has a radius length 2x and an arc length of 2 pi x, this angle is 180 degrees. Right, because 180 over 360 times 2 pi r is just pi r. So which means that the arc length just has the length pi r, but in here as r is 2x, right, this works out perfectly. All right, so this has an angle of 180 degrees. Well, this would just be a semicircle. And then to find the area, we would just use half pi r squared, which is equal to half pi 2x squared. And in here, be careful. When you take 2x squared, you have to also square the 2 as well as the x. You can't just simply only square the x. This would give you 2 pi x squared, which would be equal to 3 pi x squared. And note that this formula, right, matches this question. Because in here, we also had a total surface area of 75 pi from a base radius of 5. So 5 squared times 3 times pi is 75 pi, which shows that this formula matches and is correct. All right. All right, question 6. So in here, a spherical container with radius 6 centimeters is filled completely with water. And if we pour all the water from this spherical container into a cylinder with base radius 3 centimeters, what is the minimum height of the cylinder to be able to hold all the water without spilling? So what this question really is saying is that we have a sphere, and this sphere has a certain volume. But now we want a cylinder with base radius 3 centimeters and some height h, such that this cylinder has the exact same volume as the sphere. So we want to find the h where the two volumes are the exact same. So how do we do that? First of all, let's find the volume of the sphere. So volume of the sphere from your formula is equal to 4/3 pi r cubed, which is equal to 4/3 pi times 6 cubed. And you do not want to expand 6 cubed first, but instead, you should try to cancel out factors to make your life easier, right? You want to do 4/3 pi times 6 times 6 times 6, and then you want to cancel out the 6 and 3. So you would get 8 times 6 times 6 pi, which is 36 times 8, 288 pi, right? And then after that, we know that this cylinder has the exact same volume as the sphere. So it also has the volume of 288 pi. So 288 pi is equal to the volume of the cylinder, but the volume of the cylinder is also the base area times the height. In here, I'm using capital B for base area and lowercase b for just a base, like a base side. So this would just be and we know here that the base radius is pi r cubed, right, times h. And we know the r. So this simplifies into 9 pi h, and then we get that 288 pi equals 9 pi times h. So h is equal to 288 over 9, which again, you shouldn't be calculating like, and again, you can simplify this, right? So this would give you a final answer of 96, I think. Is it 96? Oh, no, 96 over 3. So 32. So the minimum height of the cylinder is 32. Okay. So this problem is a little different. Instead of pouring all the water into a cylinder, we decide to pour all the water into a cone, a conical cylinder, that somehow stands from its vertex. Okay. And again, we want to find the minimum height of this cone. But we are given that the radius is twice the length of the height. So if the height is h, the radius can be expressed as 2h. So again, because we're taking the same sphere, the volume of the sphere would be constant. So V sphere here is also 288 pi. The V of the cone, as it is the same as the cylinder, because the volume of the cone is the same as the volume of the sphere, this is also 288 pi, but we can also express this in terms of the volume of a cone, right? this would be equal to 1/3 pi r squared times h. But as we know that r is 2h, we can substitute and get that this is 1/3 pi times 2h squared times h. Note that this drawing is not in scale, right? And this would be equal to 4h cubed over 3 times pi. Okay, so now we just solved. 288 times 3 is equal to 4h cubed pi times this is equal to 4h cubed times pi. The pi's cancel, and we get this. Again, here, do not take 288, multiply it by 3, and then divide by 4. Try to simplify first before you do a calculation. So we would want to cancel the 4's out because 288 is actually a multiple of 4. And you would get that this is equal to 72. So now you have 72 times 3 is equal to h cubed. And then there's something you can do that's pretty simple, is you can just say that h is equal to the cube root of this. And then as 72 is equal to 24 times 3 times 3, right, which is equal to 8 times 3 cubed, this simplifies perfectly to a whole number where you get 6, right? And here, I think something that's more like computational efficiency is that you shouldn't be calculating out 72 times 3 because that really doesn't give you anything. Because in the end, you want h instead of h cubed. So your better bet would just be to take the cube root of both sides and then simplify from there. Instead of trying to multiply this out, you should try to factor it so you can get the final value of h. Okay? All right. So this is going to problem 7 is one of the like more geography questions that you'll get on the test. It's a similar type of question that you'll get on the test. Okay. So first of all, Boston, Massachusetts is located at 42 degrees north, where it is represented by this point on our Earth. Find the angle of the sun at September 21st, the fall equinox. So just to review, the fall equinox is when the north half and the southern half get the same amount of sunlight from the sun. So the sun is shining directly at the equator. So our first step is that we want to draw parallel rays. So the sun is also shining like that. It is also shining like this. And then, if we have a person that's standing here, the person would be standing like this, right? And the ground would be like this. The ground would be like this, sorry. However, the sun is shining at what angle? At an angle that is parallel to this. The sun would be going like this. So we want to look at this triangle. Right? And I'm making it bigger here. And what is the angle we want to find? We want to find the angle of the sun to the ground. So we want to look at this theta. Okay. So what do we know though? What angles do we know? First of all, we know that this is a right angle because a person standing on the ground is always going to be perpendicular to the ground itself, right? That's kind of common sense. But then we also know this angle. What is this angle? This angle is the same as this arc, right? And we know that this arc is 42 degrees, so this angle is also 42 degrees. This also means we know this angle, and we also know this is the same. So this is also 42. So now we solve for theta. Theta equals 90 minus 42. 48. All right, what about in the summer solstice? This would be the exact same logic, right? We would draw the person standing perpendicular to the ground, and we would draw the ground like that. And then, but this time the only difference is that the sun is not covering the northern hemisphere and southern hemisphere equally. It is coming to the earth at an angle, at this angle. So it is not like in the original where the sun is coming at this angle, right? Where the sun is coming like that. But the strategy is the same. We construct a parallel ray that looks something like this. And then we focus on this triangle that I again will magnify. Again, this is a right angle, right? This part is a right angle because a person standing on the ground is going to be perpendicular to the ground. And this time, we know that this angle is actually equal to 40 how much? 42 minus 22.5, minus 23.5, which is 21 or 20 and a half. Wait, no, not 20 and a half. That would be, is it 18 and a half? Yeah, 18 and a half. So this would be 18 and a half degrees. And then because these two are parallel, this angle is also 18 and a half. So we have this angle is 18 and a half. Now the final angle, which is the angle we want, is equal to 90 minus 18.5, which is 71.5 degrees. Okay, last problem. At summer solstice, the angle of the sun in Boston and another city right around the equator are the same. What is the latitude of the other city? So if we kind of go back here, why would the angle between Boston and another city be the same? Why would this angle be the same? Well, this has to be because we have a ray here. And instead of hitting, and this time, instead of hitting the ground from the left, the sun actually hits the ground from the right. Right? But this angle is the same. And why is that? Well, because these two angles are the same. Right? This angle is the same as this angle. In other words, if you go from the Tropic of Cancer and then go down a certain number of degrees, you'll form the same angle as if you go up a certain number of degrees. So our answer here is just Tropic of Cancer, which is, I think, 23.5 degrees, minus the difference between the latitude of Boston and Tropic of Cancer. Again, why? Because the angle of the sun is only going to be the same if we construct something that is kind of symmetric to the tropic, to the angle of the sun or the Tropic of Cancer. In here, we have an angle because we're not at the Tropic of Cancer, but we go up by 18.5 degrees. To have a place where the angle is the same, instead of going up, we just go down by 18.5 degrees. Okay? And then we would get 5 degrees north. Yeah. Okay. Now we have a few questions on sectors, and then we'll end this video with the challenge problem. Okay. So we want to find theta if OB is equal to 180 and this arc length is 30 pi. So let's look at the formula for arc length. The arc length is equal to the angle over 360 multiplied by 2 pi r. So we get that this is actually the same as theta over 180 times pi r. All right, and we know that the arc length is equal to 30 pi. And we know that r is 180. So we get this. And then the 180s cancel out. So we get 30 pi is equal to theta pi, which gives us theta is equal to 30. All right. Question 2. We want to find theta if AB has length 9 pi and the circumference is 144 pi. So theta, okay. So circumference happens when theta is equal to 360. So when theta is equal to 360, we have a circumference of 144 pi. However, if we only want a section of the circle, in other words, when theta is equal to x, we have a circumference of 9 pi. Here, we just want to find the theta, the x value when theta equals x. So we can set up a simple proportion, right? X degrees is 360 degrees as 9 pi is to 144 pi. The part is to the whole as the part is to the whole. So this gives us 1 over 16 is equal to x over 360. And then we get 360 equals 16x. And then you will get something like x is equal to 22.5 degrees, if I did that correct. Yeah, okay. Now we want to find the area of this sector if the arc AB has length 12 pi and the radius is 12. First of all, we have to find the angle, right? And here we know that the angle is 180 degrees because theta over 360 times 2 pi r is equal to 12 pi, right? And we know that r is equal to 12. So we have theta over 180 times 12 equals 12. And this only satisfies when theta is 180. All right, and then what do we do? If theta is 180, we can simply find the area of the sector by pi r squared times 1/2, because 180 degrees is just a semicircle, so we multiply by 1/2. And then we get that this is equal to 72 pi. Okay, final problem is also kind of my favorite problem, right? It's a pretty cool problem that I really like. So in here, the two circles are concentric, which means that they have the same center. A is a point on the smaller circle, and B is a point on the larger circle. We have that OA is perpendicular to AB. And then AB equals 10. And we want to find this area, the area that is outside of the smaller circle, but inside the larger circle, right? So first of all, let's find an expression. And for these problems, it might seem that we're given nothing, right? It might feel like we actually need, the radius of the smaller circle, the radius of the larger circle. But it turns out we actually don't need that much. And to start by doing these types of problems, it's often useful to find an algebraic expression for the area that we want. Our desired area here is the area of the larger circle minus the area of the smaller circle. And the area of the bigger circle is just OB squared, because it's the radius squared multiplied by pi, minus OA squared multiplied by pi. But what is OB squared minus OA squared? This is a right triangle, so OA squared plus AB squared is equal to OB squared. If we rearrange, this just becomes AB squared. So we take pi out, and then we simplify this to OA squared, or AB squared times pi. And we know what AB is. AB is 10, so this just simplifies to 100 pi. Okay, thank you guys for watching this video, and let me know if you have any questions. See you next time.